Many of us will have been confronted by a scene like this over our careers, lots of big old packing crates. You get a sense of rising panic as the doors of the truck swing open to reveal what resembles a solid wall of timber-framed and panelled crates. When they finally make their way into the exhibition space and populate much of the available floor area, we may speculate how wonderful it would be if we could minimise their size and weight. There's some Caravaggio crates there as part of his a very little known work by Caravaggio, but I think perhaps one of his more interesting. Whilst the solidity and commercially produced picture containers confers protection from a variety of hazards facing fragile artworks in transit, their weight presents its own risk and hazard both to the works in transit themselves, to the technicians and transport agents charged with their logistics. So it was with these mixed feelings that I received the first of several shipments from the Burrell collection in Glasgow directly into our newly refurbished exhibition gallery on day one of our groundbreaking drawn in colour Degas from the Burrell exhibition. The planning and detailed preparation had been years in the making. I had travelled to Glasgow to see the works in store and discussed the framing and hanging methods for them with the representatives from the Burrell and with the shipping agent who would bring them to London and produce the packing crates. For the Burrell, it had been a big step agreeing to lend these works to London. Most of them had not left Glasgow since entering the collection. A freelance paper conservator with experience in pastels was engaged as a consultant early on in the project, and it was her experience of working on a number of pastel shows, including Beyond Impressionism with the National Gallery, that informed the principles underlying how the pastels would travel to London. It had been agreed at the outset that the well-established principle of transporting the pastels flat would be adopted in this instance, as previously the cases would be multi-pack with a maximum of 3 pastels in each. But due to the large size of many of the pastels, the cases would need to be big relative to the size of the individual works and would take up a large floor area, as you can see there. I mean, some of those crates are kind of akin to a hot tub, you know, albeit a small one, but consequently, there was a discussion about how many cases could reasonably be brought in at one time and where we would unpack them and store the empty crates prior to removal from site by the shipper. In the months prior to the installation of the show, a multidisciplinary team of exhibition managers, conservators, gallery technicians, and shippers consulted over the style and construction of the crates, each stage guided by the requirements of the Burrell and their advisors. When we worked with the Art Institute of Chicago on our joint Beyond Impressionism exhibit in 1996, it had been decided that there would be a divergence in approach to the way our respective packing cases were configured. Chicago opted for a lightweight composite material triple case with 3 drawer trays in the inner crate. We had opted for a simpler and arguably less sophisticated timber double crate system, also comprising 3 trays, but simply stacked atop one another inside the outer case. If you want to grab a view of that guy there contemplating his destiny over the next 23 years, staring into the void, there he is. Of the early principles jointly agreed between the parties for the construction of the crates was that the pastels would travel flat. The objects would be double crated at a minimum, and that the crates would contain multiples of up to 3 separate pastels. 3 specialists at the National Gallery were appointed to oversee the processes leading to the delivery of the show in London. Lynn Harrison, paintings conservator, Ulrika Danielson, exhibitions manager, and myself, the senior technician in charge of the installation. All 3 of us paid site visits to Glasgow on separate occasions, to the Glasgow Museum's storage facility in the east of the city. There we met with colleagues from the lender and to have an opportunity to examine the works in store. My visit was made along with a project manager from Constantine, the agent appointed to undertake the transport and construct the crates. I was able to discuss what hardware was to be used, how works would be individually wrapped, and what materials would be used. I also used the opportunity to look at many of the works selected for the show in the storage facility. I discussed the crating with the Burrell team and looked at a large single lay-flat crate which had been used by them previously to send a single work to Australia. This crate, it was decided, would also be reused to send the same work to London. You'll see that crate there, in fact, in the exhibition space at the National Gallery, being decrated, and you get an idea of the size of it. The Burrell install took place over a week and a half. Many of the logistical problems on the ground had been anticipated. We knew what the cases were going to be like, their size and weight. As part of the loan agreement, rigorous protocols. Have I missed out a bit?
You've missed a bit. That bit there.
Oh. Thanks, Lynn. Let's go back. There we go. Okay, so just to give you a little bit of context, before we entered into this process with the Burrell, we had an opportunity. You'll have to understand, we have very few. Well, no, we do actually have quite a number of pastel works in the National Collection. They don't often travel. This, however, was an exception to that, and aside from any exhibition input that we were involved in at the gallery, this was Perronneau to France, to the Musée l'Orléans, which we took there last year in the run-up to the Burrell show. Lynn and I had a valuable opportunity to test out some of our theories. The gallery lent a Perronneau pastel to the Musée l'Orléans. This was a straightforward door-to-door run in a truck taking under a day. We configured our crate and included a data logger, the first of many monitored runs with a lay-flat pastel crates, and you can see the three stages there. That's the inner crate loaded with, well, effectively no cushioning whatsoever. The work is held there very rigidly in plastizote pads. There's the crate, the conservatives crate in this instance, which has been configured for the weight of the pastel tray and the pastel painting. And here it is. Okay, we've got two works here. There's the pastel, obviously laying flat and ratchet strapped to the floor. And that's a further loan that we extended to Orléans, which was an oil painting, which is ratchet strapped to the side of the truck conventionally. The Burrell install took place over a week and a half. Many of the logistical problems on the ground had been anticipated. We knew what the cases were going to be like, their size and weight. And as part of the loan agreement, rigorous protocols relating to minimizing shock input through the careful routing of works entering the gallery had been devised, as had minimizing unnecessary handling whilst unpacking, condition checking and installing the works. These had all been discussed with the lender as part of the loan agreement. Happily for us and the Burrell, the condition of the works on unpacking indicated that all had worked well during the transit. The pastels were unchanged and had survived beautifully their 400-mile journey from Glasgow. Various possible case configurations had been discussed during the planning stage for the show, and key aspects of decision-making regarding the final case design was in the hands of the lender and the paper conservator consultant and in-house conservator. Time was short and ever shortening, as is often the case, with large complicated shows. Whilst we had our own ideas of what we would specify for our own collection, there was little to be gained in us pressing for our ideas to be adopted over the lenders. We reached an amicable accommodation over the final design of the crates. And whilst this was a collaborative effort, we recognise the exceptional nature of the loan and the importance of providing every reassurance possible that the pastels would not be damaged and would be safe in our care. Some of the larger crates proved challenging to handle and unpack. Their size meant that the space in the truck was tight. Transferring them to the tail lift and placing them onto dollies wasn't straightforward. Careful handling was paramount, but the size and weight of the individual crates made it a challenge to avoid shock input whilst transferring from truck to gallery space. When we came to decrate the works, the weight and height of the inner trays proved a further challenge. The interlocking cleats that secured the trays together in the outer crate held together rather too well, making it difficult to extract the trays individually. You can see there, they're large. Ultimately, it was decided that we'd empty each tray whilst in situ inside the crate, then remove the empty tray before moving on to the tray below. This way, we minimise the weight of the trays by removing each lid and the work inside before moving down the stack. By the time we reached the third and bottom tray, access was easier, and the effort required to remove the work was minimal. In the interest of maintaining the structural integrity of the crates, it was determined that only the lid and front panel would be demountable. I had argued for a second removable side panel, but there was a concern that this may weaken the case and cause it to distort during transit. There was also a requirement for each tray to have its own lid. Once again, structural integrity was cited as a reason for this, along with the preservation of climate conditions in the tray. I'd maintained that by using the base of the top tray, the second and third trays could be sealed without the need for a separate lid, and that the conditions could be maintained with the inclusion of a simple gasket around the top lip of the trays. Thus, only the top tray would require its own separate lid, reducing the weight of the loaded crate considerably. Once the show had concluded, the pastels returned to Glasgow. We decided to explore some of the issues that had risen from our experience. We were at liberty to play with the configuration of the crates we had agreed on with the barrel and make our own changes. We were curious to see if the inclusion of a further removable panel from the outer crate would cause structural flexing in the crate, and if the omission of separate lids could have a further detrimental effect on the performance characteristics of the crate. Constantine very generously provided us with a bespoke crate which conformed to the exact same external and internal dimensions of one of the typical barrel cases. Our crate had 3 demountable panels, the top, front, and one side panel. This left only 2 trays permanently attached, 2 sides, permanently attached to the base. Internally, the 3 trays were constructed from thinner plywood, and only the top tray had a lid. The 3 trays nested inside the shallow, vertically raised extensions or cleats at each corner to prevent movement between the trays. I think you can see that there on the first slide. So we have some vertically extending corners there, and that effectively locks those 3 trays together, creating a considerably heavy block. Before testing began, one notable benefit was the decrease in weight compared with the exhibition cases that we'd used. There was a saving of 51 kilos, or nearly 113 pounds, in fact. The second removable panel exposed 2 sides of the internal stack of trays, making it easier to get hold of individual trays and haul them clear of the case. These trays were now much lighter. Our experience using the exhibition specification cases have been positive. The pastels had not undergone any changes in condition. No losses have been noted from the pastel medium of any of the individual works. But we had struggled at times with the sheer bulk of some of the larger crates. To some extent, I felt the mitigations that have been thoughtfully and rightfully put in place to avoid subjecting the pastels to shock and vibration might be compromised through the difficulties of handling large and bulky crates in confined spaces. Increased accessibility and weight reduction were the prime motivators behind the redesign of the case. Ensuring that these 3 goals weren't at the cost of diminishing or diminished performance characteristics of the original design was paramount in assessing our efforts. We therefore set about devising a series of tests directly comparing the exhibition crate with its experimental double. This ranged from monitored road transport to numerous monitored circuits around the gallery precinct. Now for the science part.
Not quite, I'm a conservator. So thanks, Mark. So I'm going to take you through a snapshot of the results of the second part of our presentation. I'm going to go quite fast to catch up. So we had two main research questions. How did the Burrell pastel cases perform? Did they protect the artworks from shock encountered during their journey? Did the reconfigured case compromise or indeed improve the level of protection given by the Burrell cases? Now, before we look at the data, we'd like to stress that this research is current and it's ongoing, and it's driven by a desire to understand more fully what kind of protection the multi-pack lay-flat cases can provide, and how we might go about addressing common problems that we all encounter when artworks are moved. And this does, to me, seem particularly pertinent in today's climate of increased loans and exhibitions programming. Looking at our collection, I wanted to consider, as a conservator, how this research can feed into our larger loans programme for our old master paintings, for the panel paintings, and for paintings that haven't previously been lent due to their fragile condition. It seems essential that we understand what we are exposing artworks to and what that cumulative effect of this exposure may have on their future condition. So the data we're presenting here are the results of our latest and my first foray into this, what I consider a spectacularly complicated world of shock, vibration and vibration mitigation. For testing, we've made use of a Lamholm 298 shock logger that records acceleration levels in 3 perpendicular axes in gravity units, or G. In our presentation, I'll therefore refer to shock levels and events, although the impact of lower level, longer duration vibration, as you've seen this morning, can't be ignored. To date, we've had a look specifically at the shock mitigation provided by the Burrell cases, and by comparison, the performance of our reconfigured case. So we did some basic monitoring during transport of the Burrell's Degas pastel collection to and from the National Gallery. And to be honest, this proved more an exercise in trying to get the shock loggers to work. But we did establish that the shock loggers would indeed give us some useful comparative data, and that the internal environment inside both cases was very stable. So our reconfigured case did not compromise this. To date, we've undertaken 4 test scenarios. A 4-hour air ride truck trip around the countryside around London, a 15-minute round the gallery circuit, which we've done a few times, a number of drop tests, and finally we looked to see if there were differences in performance between the top and the bottom inner trays. So if we look first at the road trip, one shock logger was attached to the outside of the Burrell case, one inside and one inside the reconfigured case. The positions of the loggers, as we heard this morning also, have an impact on the data and how the data compares, so we've tried to be as consistent as possible. So as you can see, as expected, loading and unloading created the highest shock levels, with levels around 4.2 G. This was on the outside of the Burrell case. Inside, the levels were approximately halved for the shocks, and we're looking here at the moment in the up and down direction, which was the x-axis in this case. For the journey itself, trundling along the road, the inner trays experienced discrete shocks of up to 1.5 G, but levels generally remained below 0.5. So looking in a bit more detail of the journey itself, here I show the shock levels of each of the 3 axes, with the data in blue being for the outside of the case. In the direction of travel and up and down, the shock levels experienced by the inner trays was at times greater than that recorded on the outer case. Side to side, however, the shocks were lower for the inner trays. So if we look in detail at the data for one shock event, and here I show the data in the 3 axes for the outer case in the top graph. So comparing these graphs, we can see 3 effects. Firstly, the high-frequency movement side to side of the outer case is reduced for the inner trays in both intensity and frequency. Secondly, movement up and down of the inner trays appears to be amplified. And finally, probably because of the foam, movement of the inner trays is occurring at lower frequency and slightly more sustained than for the outer case, so for a longer duration, it's not dampening so quickly. Now, we think these differences between the outer case and the inner trays may have something to do with the cases being ratchet strapped tight to the side of the air ride truck, and the truck being pretty much fully loaded and therefore functioning well. It appears that the inner trays are in fact moving around slightly on their foam pads. So next, we walked our cases on skates through the galleries, encountering various floor surfaces, and the shock loggers were in the same position and orientation as for the road trip. Riding over the door jambs and lift entrances around the gallery created shocks of about 1.5 to 2 Gs. Again, we're looking at up and down direction. And there appeared to be little difference between the inner trays, which are shown here in red, shades of red, and the outer case, which is in blue on the graphs. But in some instances, as with the road trip, shock levels recorded on the inner trays were higher at times than for the outer case, suggesting movement of the inner trays on their foam pads. Interestingly, the shock events for the barrel case were more intense and of short duration than for the reconfigured case, where events seem to be of a lower intensity but of longer duration, so they're more spread out. We're thinking this may be the consequences of the reconfiguration of the outer case and probably the reduced weight of the inner trays. Inspired by the road trip, we ratchet strapped the reconfigured case to see what effect this had on its performance. It did seem to make little overall difference to the levels of shock experienced, but interestingly, it altered the profile of the shock events, which now appeared closer in character to the barrel case. So we suspect, again, this is because we've made the system stiffer by ratchet strapping it together. We performed a series of discrete drop tests to see how well the outer case buffered the inner trays for high-level shocks. The shock loggers were again attached to the long arm-brace side of each case, inside and out. But note that for this test, the block is being pulled out along the Z-axis direction. Both outer cases, that's the data shown here in blue, performed in similar ways, offering good protection for the inner trays, which is the data in red, by reducing the shock levels considerably. Overall, the buffering of the inner trays of the reconfigured case seemed to perform slightly better than the barrel case, except in the Z direction, which I've pointed here on the slide, where the performance seemed worse. We then ratchet strapped the reconfigured case for comparison, and I've zoomed in a bit here for you. You can see that strapping has certainly altered the behaviour of the inner trays. It seemed, strangely, to make things marginally worse, except in the Z direction, where it was considerably improved. Finally, we've compared the movement between the top tray, that's on the graph, that's the peak shade in shades of blue, and the bottom tray in red, in the multi-pack system of the barrel case. These are initial results, and they seem to indicate that there is slightly higher shock levels experienced in the top tray than in the bottom tray in all directions. However, the dampening behaviour in the top and bottom tray is extremely similar, but we need to look at this in more detail. It's just our first tests. So after this quick resume of our round of testing that we've undertaken, we've been able to draw some general conclusions. Our tests have showed that, on the whole, there's very little difference between the original barrel case and the reconfigured case. Our modifications had not significantly altered the performance of the case, but they had contributed significantly to improved handling and packing. Both case configurations seem to function well at mitigating isolated large shocks in the region of 8 to 12 G. The cases do, however, offer less protection for the inner trays for lower level shocks in the region of 1.5 to 2 G. The drop test suggests the inner trays are swaying or moving on their foam pads. The inner trays of both cases performed similarly in the X and Y axes, but in the Z axis they differed, with the barrel case restricting movement of the inner trays far better, or more, than the reconfigured case, We think this swaying may relate to the lighter weight of the inner trays and perhaps some movement in the joints between the 3D mountable panels of the outer case. Strapping the reconfigured case offered better buffering for larger shocks. However, strapping altered the profile of the shock events for low-level shocks from low intensity but longer duration to more intensity and of shorter duration, in fact to the similar profile of that of the barrel case. And we would welcome discussion on the significance of this, both in the case structure and also in relation to what's happening to the enclosed artwork. Something to think about. Initial testing has also suggested that marginally higher shock levels were experienced in all three axes in the top tray compared with the bottom tray in the multi-stack system. So it may well be appropriate to consider placing more fragile artworks at the bottom of the stack, but we should probably test this more. Sorry that was so fast. I'll hand back over to Mark to finish up.
Okay, guys, well, that pretty much concludes our presentation. I think we may have overrun slightly. Just a little bit about, us and the privileged position that we occupy, as being part of a team in a well-funded public gallery. We're a publicly funded institution. We have considerable resources at our disposal, the backing of our colleagues and the support of industry partners to undertake these experiments. Despite these manifest benefits, as I'm sure many people who've tried these things themselves will find, finding the time to undertake these investigations is just as challenging. As the end user of picture containers for both pastels and oil paintings, it is incumbent on us to ensure we transport our cultural artifacts in a safe, effective and sustainable way. And I consider it part of our job to look at how we do this and ask if there is a better way. Novel materials are increasingly being incorporated into the design of art crates, much of which can be swapped out and installed in other containers further down the line. Maybe we're on the cusp of a big leap forward in the technology underscoring the movement of cultural artifacts in the future. Who knows? But what I'm sure of is this, that the technology already exists. It's just a matter of applying it in a sensible and measured fashion. What we have learned from our experiments is that small, seemingly trivial alterations to design can have subtle and unexpected effects, some which are beneficial, others less so. But with some inventiveness, ingenuity, and scientific rigor, the ridiculous can indeed become sublime. Thank you.